Well, I don't know if you noticed, but Mocha did. She discovered a little mistake I'd made in my presentation 1.3. If you look carefully, what you'll see is that I've put in originally the wrong conversion for density. And if we just check that again, in actual fact, the density at grams per litre is the same as kilograms per cubic metre, which is 1, so I've just corrected that. And hopefully we can move on from there, not too bad. So we've got our salinity related to density, but what we really wanted to work with our instrument is specific gravity. And specific gravity is a ratio. It's the ratio of density of one substance to the density of the other. And in our situation, we're going to use the reference density of fresh water. So let's have a quick look at what that means. Fresh pure water, in fact, it's defined as fresh pure water at 4 degrees centigrade. We can look at that further. So if we put that formula in, and if I just move this out of the way, we can kick this calculation right across and see that in actual fact we've got our specific gravity measures related there. And of course these relate to salinity because we're talking about density again. So now when we've calibrated our instrument, we can then make a conversion chart. And I've made a simple table conversion chart here. This is what it looks like. So we've got on the left-hand side here the representation of our instrument, our hydrometer, 1.1 our scale, and we've got our specific gravity measures, remembering that it's the bottom of the meniscus, where the bottom of the meniscus is, that gives us our reading. And we now know the conversion because we calibrated it. We've calibrated and set a standard here and calibrated, and our 0.005, which is 5 parts per thousand, is just between the 1 and the 1.01. We can see where our normal seawater is, and we can see the length of our scale there. So that's not an uncommon thing to find in science, is a conversion scale or a calibration scale, and it's going to be useful. So when in our experiments we get a measurement that looks like it might be 1.045, then we know that probably we're looking at a 45 parts per thousand. Another way to do it, if you do have a laptop, is actually to make a graph with the conversion, the relationship between salinity and our specific gravity. We can use this graph to interpolate. So we can take from the x-axis our specific gravity measure, come up to the graph, and then across to the y-axis we can read off the salinity. Another, probably more advanced way to do the conversion is to take your graph, graph a linear regression line, and then click on the show the equation. Get the equation for the graph up on your conversion graph, and then when you've got that, copy it when you've copied it, you can paste it onto your experimental spreadsheet. This will allow you to convert your readings from your specific gravities in your experiment directly to salinity in your spreadsheet. And again, you know, the old trick of once you've entered that, you can simply form the small black cross at the corner and drag it across or drag it down, and it will carry the formula and do all the calculations for you in relationship to your data in the table above. We've dealt with another source of error here. That's sort of recording and calculation error, something you have to be aware of. We'll look at this in more depth in a future topic. The other error that we haven't looked at here, but we will look at in the future, is statistical error. And now we're going to move on to review the whole topic and look at how it's applied. Are you happy with that, Mocha?